feeling at all well today. I was home yesterday sick, so I'm probably, like, as soon as I'm done here, I'm going back to bed. That's there. So, all right, let me go ahead and get started here a little bit. There should be I posted a lecture the last Thursday on the campus, on the website. Some of the young ladies said they haven't watched that yet. Has anybody seen that lecture? It is up there, isn't it? Has anybody watched it? Yes, one person admits to watching it. It's like 50 minutes or something like that. It's not a full hour, 2 hours up there. Okay, because I finished up that chapter, and I don't have the slides with me for the next chapter, but that's fine. I'm going to go ahead and just basically, as soon as I find my, up there, right here. I'm still working out of the Tochi book up there. And the next chapter is chapter 4. Get there. And chapter 4 is really where we start doing our, there. Before I get going through here, let me just kind of go back to chapter 3 here. And the reason I'm coming here to chapter 3 is there's some homework problems in chapter 3 that I want to just kind of point out that you should be looking at right there, because these are where the final exam questions are going to come from. That's there. And everyone should have an e-book version of this book up there, so you should have access to these problems. So I'm not too concerned about drawing draw the output waveform. That's fairly straightforward here. This is an OR gate, and I'm just going to kind of go through some of these problems today. So, as I said, up there, and kind of talk about a little bit about this right here. This particular right here, but as you look at this here, is any place that A, B, or C is high, the output is going to be high. So the only time the output is going to be low is, like, for example, this period right here, where this input is low, this input is low, this input is low. As soon as it goes high, low, and then it stays, it's going to go high here. Well, anytime any of these three inputs are high is when you're going to have the output high. And up there, that's an OR gate. Up there. Now it says, draw the A. Suppose the A input is unintentionally shorted to ground. So as you look at problem 2, up there, you're assuming that this one is all low. So then you're going to base your signal on just these 2 inputs right there. So, again, these are the questions that I'm going to be pulling for the exam. So that's why I want to make sure that you do 3-1, 3-2. Problem 3 is, again, this is a troubleshooting problem. It says assume that the A input is unintentionally shorted to 5 volts. Well, that one's fairly easy, because if you short A to 5 volts, then the output is going to be just 5 volts right there. In other words, if A is accidentally tied to VCC, then your output is going to be high. So, up there. And then again, we repeat the problem with an AND right there. Right there. So, there. So you would, let me just kind of write these down here. Right here. So you should look at problems raw. So 3. Okay. So you should be looking at problem 3.1, 2, and 3. That's for sure. Those problems are definitely open game right there. Right right here. So as we look at, 3-1, 3-2, 3-3, and then 3-6 is the next one there. 3-6 right there. And then if we go through here again, we go back to here. 3-4 modified up there. We haven't talked about up there. As we look at the next one here, here again we're looking at apply the A waveform from figure 3 to from figure 3.23. Okay, that's earlier in the chapter, right there. These figures. Sometimes this book will go back to previous figures here. And as we go through and look at this right here, I would not, let's see, which figure did it say? 3. Draw the waveform. Okay, that's the first one. Okay. 323. So you would have to go to figure 323, find that figure to the input of the inverter, draw the output waveform now out there. What I'm more interested on this one here is 312. 312 is definitely, well, that does some funky things there. Right there. That's right. But 312 is definitely a problem I would ask. 312. In other words, you would write the expression for that schematic right there. So as I go through and look at this there, 3-12 is a problem that I'm going to star that one. You definitely need to know how to do that problem right there. So as we go through and look at right here, construct the following logic circuit. Again, 316 right there. So 316 is a problem that I would ask right there. So 3-16 up there. Right here. Again, 316 covers all these right there. That's there. So again, I will not ask something where we'll be looking at doing simplification here in this next chapter. I'm going to be talking about card-off maps here in a few minutes. So 326 is one that I would probably ask you to do. Actually, 324 and 326. So let me just write those down here. 324 and 26 right there. So there, and that's probably all the homework problems that I would probably hit you with out of this chapter right there. So, all right. You see there's a lot more there, but I'm just going to limit it to that there. Now I'm going to move into the next chapter. I don't have the slide for this, so I'm just going to kind of wing this here, right there. And we're going to be looking at working things on sum of products form. We've already talked about sum of products right there. And we're going to be looking at using Karnoff maps. That's what we're going to be looking at today, right there. So as we go through and look at this chapter, this is what I mean by a sum of products form. And that's what I've been using here. That we've got, let me just jump in here. Right there. If we've got a 3-input system, A, B, C, right here, and I'm going to show X as my output right here. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. 1, 0, 0, 1, 0, 1, 1, 1, 0, got this right, and 1, 1, 1, right there. These are all of our combinations right here. Right there. These are all the combinations we can have in terms of this circuit right there. And I could put any output that I want, any function of A, B, C. In other words, this output is a function of A, B, and C, my inputs. And I just put random numbers there. In other words, 1, 1, 0, 1, 1, 0, 0, 1, right there. I just made those numbers up as random. Okay. I can write that function by looking at this table. In every place there's a 1 here. Right here. Every place there's a 1, I would have a term for that right there. So, and each one of these terms is going to be right here. This top one here is A naught, B naught, C naught right there. This one is A naught, B naught, C. And all I'm doing is, if it's a 0, I put the letter naught. If there's not a 0, I just put that there. So this one here is A naught, B, C right there. This one is A, B naught, C naught, and this last one is A, B, C right there. So this function is simply these all OR together right there. So I can write this function down as the sum of products just by inspection right there. Is this in the simplest form? No. I could probably simplify this by using the rules of Boolean algebra, but I can write this function down very quickly and say that this function is A naught B C naught, or A naught B naught C, or A naught B C, or A B naught C naught, or A B C. Right there. That's what this function is. X is equal to X. This is in standard sum of products notation, and we'll use that there. And I can very easily implement that there. Now, if we're using programmable logic, and I kind of skipped over programmable logic in last Thursday's lecture. Those of you who saw last Thursday's lecture, you probably saw a slide where it talked about programmable logic, where this could actually be done very simple, that there by fusing, blowing fuses that there with programmable logic there, or within a field programmable gate array or something like that. This is a very simple circuit there. Now, what we're going to be doing is we're going to be trying to simplify this by using something called a Karnaugh map. And Karnaugh maps are the easiest way you can simplify a circuit. Now, I hesitate to go into great detail on Karnaugh maps, but they will be on the final exam. You will be expected to know how to use them. I have not used a Karnaugh map to simplify a circuit in a long time, because typically I use programmable logic. 90% of doing it, digital logic today is using programmable logic. So we're learning basics here, but keep in mind that you're probably not going to do a lot of that. There are some cases quite honestly, when I took my professional engineer's exam 20-some years ago, I had to take, the problem required I use a Karnaugh map for simplification. So looking at this right here, a Karnaugh map is basically a way of putting this into a table right there. And let's just look at here, and this may be different. Let me pull up the book. Let me do it the same way the book does it here, right there. And I'm just skipping up through a lot of this right here. And I'm skipping a lot of this. Okay, turn off maps 4, 5. All right, he does it this way. Okay, let me do it. Let me follow his notation right there. There's more. You can do it you can do it this way or you can do it that way. It doesn't matter. But since he does it this way, I'm going to follow that notation. So right there. So going his route, he does A, B, and C across the top. Okay. So let me erase this and follow his notation. Right there, A, B. Now, right there. Now it looks like I made a mistake there, but this is done using a grade code. The way the turn-off map works is that only one variable changes when I move from one cell to the next. So this is 0, 1, 2, 3, 4, 5, 6, 7, right there. So they're in order. They're not in order as you would normally expect them to be, because as I move from this cell to this cell, A goes from A naught to A, right there. If I did it in the other order, the other way, both A and B would change. So, and I can't have that. I have to do it one cell it can change at a time. So you just basically have to accept that right there. So what I'm going to do is I'm going to put this into the turn-off map. In every place I've got a 1 in my table here, I just simply put a 1 in the map at that point, right there. And so as I look at this table here, I've got a map and a 1 here. Looks like 0, 1, 2, 3, 4, 5, 6, 7. So it looks like 7, 4, 3, 7, 1, 4, and then 1, right? Yeah. So I've got 5 1s in there. This is a 0, this is a 0, this is a 0. And what we're going to do is we're going to read these out in the largest groupings that we can read. And we're going to group these together. Now we can read in groups of 1, 2, 4, or 8. Right there. So when we look at this here, and we also have to realize is when we look at the groupings right here, this is a group of 2 right there. This is a group of 2. This is a group of 2, and this is a group of 2. You have to realize that these 2 are connected to each other. Every circle that I draw represents a term that's in the output equation. And what I do is I started with a pretty messy one here. I apologize for it, but we'll go through multiple examples of these here, right there. This top group here, right here, let's just look at this group right here. This group of 2 right there. We look at what changes. And what changes as we move from right to left is C, right? Right there. So when we look at those 2, each of those terms are, and is A naught, B naught, C naught, or A naught, B naught, C, right there. Now, if I apply Boolean algebra to this, I would factor out A naught, B naught, C naught plus C, right? Well, C naught plus C is what? 1, right? So that goes away. So I can simply write this group of 2 with just this right here. I eliminated C naught. And I do that without applying the Boolean algebra. I just read it. This is a method of applying Boolean algebra using the table and not having to go back to the rules and memorize the rules. Right? So this group of 2 right there is just A naught, B naught. The C disappears. And the way it can disappear is when I write those 2 there, I can see that the C would disappear. Again, I'm applying Boolean algebra to right there. So these 2 terms right here represent those from the expression. I factor out A naught, B naught, and then C plus C naught right there. That disappears, and I'm left with that right there. So the same thing when we go from top to bottom right here. What changes there is the A. Right here. As we go from here to here, notice that the A goes from A naught to A right there. So now I can reuse ones, but I have to make sure all the ones are circled. So when I do that, right there, that term right here, this circle there, becomes simply B naught, C naught right there. That group of 2 there. That right there. Same thing when I go from here to here. It's the A naught changes right there. So that's plus BC right there. That's this group of 2, and then I got this group of 2 here, and that's A naught B right there. So my full expression, and let's just do it from the start. Let's just go through and pick each group of 2 and write them down. I've got 1, 2, 3, 4. I have 4 terms in my answer right there. So the first one, let's take the one that wraps around. That's B naught, C naught, right there. The next one, the one that's across the top, is A naught, B naught, or that's this group here. This group here is A naught, C, or the last one is B, C, right? That's my simplest expression I will get from that term. Right there. That is my simplest expression. So, and we'll do some more of these right here. Again, I'm starting off with, I could go through here again and simplify this by hand, and I should come up with that same expression. It will take some time, but we're not there. But there. So this is kind of black magic about how we're going to get our simplest circuit from a random truth table. Let's do another one. Right there. And I'm just going to write A, B, C. Right? And I'm just going to pick up, right there. All right. So let me go ahead and put my Karnoff map here. Okay. Now let's just go through here and 1, 1, 1, 1. 4, 0, 1, 0, 1. Okay. Now this one's fairly easy. Right there. And as we look at this, remember, what is our largest group right here? Do we have any groups of 8? No. Groups of 8 is easy. No, right there. But I got 2 groups of 4, right? Here's a group of 4, and here's a group of 4. Well, if I have a group of 4, that means that 2 things are changing, right? As I go from here to here, B goes from B naught to B, right? And as I go from here, C goes from C naught to C. Right there. So the only thing that's constant in those 4 is the A naught, right? So if I have a group of 4, I will only have one term. So a group of 4 is going to just be A naught right there. This group of 4 is just C, or C. This is my expression. Right there. That is my expression right there. So any place in A naught or C, right there. And as I look at this right here, I can see that. If C is high, the output is high, right? If A naught is high, then the output is high. So I can see that, but you normally would not see that by inspection, unless you've been doing this for a long, long time. But as soon as you put that in the map, that pattern shows up real fast. We have the 2 groups of 4 right here. So this is our simplest expression right there. We can't come up with a simpler expression for that. Right there. So again, this is practice. I'm going to continue to go do a couple more of these, and then we're going to move on to 16 input right there. If you can do this using up as many as you want, but they get very messy. This works really good for 3 and 4 input circuits. It doesn't work so well as soon as you go to 5 inputs. You can do it with 5, but it's not the easiest way of doing it. So, okay. All right, again, I'm just going to draw. I probably should just A, B, C. There. And again, I'm just going to randomly put these. The last one I kind of fed to get something that I wanted. Let's just do 1, 1, 0, 0, 1, 1, 1, 0. So that's there. So as we do our Karnoff map, right here, right here. Right there. C. Right there. So there's our Karnoff map. So we just go ahead and put our 1s and 0s in. Right there. So I've got 1, 1, 0, 0. Then I come down here, 1, 1, 1, 0. Right there. So there's that's my Karnoff map. Again, I look for the largest groups. Now this one's a tricky one because I have a group of 4. But my group of 4 spans here and here. That's it. Students will always miss that group of 4 right there. But we have a group of 4 that they're on top and bottom. Think of this as a cylinder that wraps around, and the 2 of those are touching right there. So there's a group of 4 there, and then I have a group of 2. Right here, here's a group of 2 right there. So in this particular case, my function is my group of 4 will only give me one term, and it looks like it's B naught. Because as I look, again, as we look at here, man, as we move from here to here, C changes, right? And as we move from the bottom to the top, the A changes. What's consistent in all 4 boxes is B naught. That's it. We're looking for what is consistent in all 4 boxes. In this case, that's there. So this becomes B naught right there. In this group of 2 here, what is consistent is A C naught, or A C naught right there. And that is my function right there. That's my simplest function right there. Right there. So, again, it's very easily done by inspection right there. That's it. So we went through all those rules of Boolean algebra, and I really didn't make you solve any problems with it. Right? We're jumping into, and the reason I'm not making you solve too many problems with that is because you would normally not use Boolean algebra. You would use this method here. This method actually is much easier. So, okay. As I said, I'm not feeling real well, but I'm going to go ahead. I'm going to expand this to a table of 16, 4 inputs. And we'll do one example, then I'm going to stop at that point. That's it. Because this is a big deal. This particular topic, and if you look at chapter 4 in the textbook, I'll go back to that there and kind of highlight what's in the first 4 sections. I just jumped right to the meat of the chapter right there. So let's go ahead and do another page here. And let's just do these. And hopefully I've got enough room. Okay. Okay, this is, again, just as the table here, and I'm just going to put random 1s and 0s on the output there. Okay. So just random 1s and 0s. Now, our table in this particular case is going to be a square. Right there. right there. Not a very good looking table, but right there. So again, we're going to, let me go back and let me bring up the book. That way I'm consistent with the way he draws it there. Let's see. All right, he puts AB across here and then CD across the top, right? So again, this is out of the book right there. So I just want to make sure it's following the same pattern. Right there. So A not B, A B, A B not. Right there. C not, D not. Right there. Notice that I did the same thing across the top as I did across going up and down. So my numbers are going to be 0, 1, 2, 3 right there. Notice that I got there 4, 5, 6, 7, 8, 9, A, B, C, D, E, F right there. So again, I go 2 and skip right there. So 1, 2, 0, 1, skip, and then back. Same thing, I'm going row, go 2 rows, skip, and then come back right there. It's a nice, neat little pattern. The reason we do that is because we want to only have one variable change when we move from one adjacent cell to the other. Now this table is a little tricky because again, you wrap around the top and the sides right there. And the 4 corners will form a group of 4. So you can have all kinds of different patterns here. Before I do this, let me just kind of basically say is that this cell is adjacent to this cell is adjacent to that cell, right here, this cell, and this cell are adjacent. These 4 corners are adjacent to each other. These 2 are adjacent to each other. So you've got all kinds of possibilities on this here, and this just takes practice. So when I say practice, it means that's there. As a matter of fact, I could probably turn right around and give you 4 or 5 of these and just say, turn them in next week on Thursday right there. As a matter of fact, I probably will give you 2 of these to solve, and I want them turned in, when we come in on Thursday. Assuming I'm healthier on Thursday. So let's go ahead and start doing this here, and I'm going to go ahead and just put the zeros, 1s and zeros in. So this is 0, 1, 1, 0, right? And sometimes it helps to go ahead and put the numbers here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So let's just go through it. Just 4 and 5 is a 1. Right there. 8 and 9 are a 1. Right there. And C and D are a 1. Everything else is a 0. Right there. Okay. Did I do that right? Someone check and make sure I'm not messing these up here. So, all right. Now we look here and we look at our groups right here. I see a group here, and I'm just going to use the highlighter here to just kind of show my groups here. This is a group of 4, right? See our group of 4 there? Now we want to do these in the largest possible groups that there. Sometimes when we do this here, we're going to see that, for example, this is a group of 4 here, and then this is a group of 4 here. So I got 3 groups of 4, and I can't not use all 3 groups there. So I got 3 groups of 4, and then I've got over here on the side a single group of 1 right there. I cannot pair that with anything else right there. I can go adjacent to this one here if it was adjacent, or so I can't, this is a 0, so I can't group that there. What? Oh, right here, that should be a 1 there. Okay. You guys caught me that there. No, this should be a 1 then. Okay, so in that case, then I can pair that up with that right there. With that being a 1, then I can make a group of 2 here. That's it. So thank you, that's there. Actually, again, that's why I asked, because it's very easy to make this mistake. That's why you need to practice. That's it. Hopefully, when you're doing it on an exam, that's there, you can concentrate more than trying to explain while I'm writing. So it's much easier for me to make these mistakes. That's there. But I've done this multiple times. So, all right, now I've got here, let's go back to the beginning. I've got 3 groups of 4, right? A group of 4 is 1 term. Here, let me just kind of write this out here. So that if we have a group of 8, a group of 8 is 1 term. A group of 4 is 2 terms. A group of 2 is 3 terms. And a group of 1 is 4 terms. That's how many variables are going to be in for that group right there. If I have a group of 16, that's 0 terms. A group of 16 means that the function is just a 1. Doesn't matter what the inputs are. So as we look at my group of 4, let's take this first one here, that term is going to be C naught D, right there. Yeah, because as I go through here, what stays consistent within this here? This is a row, everything is C naught D, right there. Right there. This group here is going to be B, right here. Going from here to here, the A changes. Going from here to here, the D changes. So this is going to be B, C naught, right there, this group here. This group here, this group of 4 here, is going to be A, C naught, right there. So as we here, what changes from there to there is A, so A drops out, so it's going to be B naught, C, D naught. So each one of these groups, and I wish I had more colors, but each one of these groups here, right there, let's look at the first group here, and that's this group here. That is going to be, and I'm just going to write it right there, that first group is going to be C naught D, right there. That's this group here. The next group is this group here. There the A disappears. And the D disappears. Because as I move from this cell to this cell, D goes from D naught to D. So it drops out. So I go from here to here, the A goes from A naught to A. So it drops out. So that's going to be B, C naught, right there. As we go to this group of 4, the B changes here. We go from here to here, and from here to here, the D changes. So we're for A, C naught, right there. And then my last group, those are my 3 groups of 4, and then my last one is this group of 2 over here. And as I go from top to bottom, the A drops. A goes from A naught to A, right there. So this is going to be B naught, CD right there. So this is the simplest response that we're going to get for that right here. What's that? This is CD. Oh, yeah. Yeah. Problem is I is that I moved that and up there. Yeah. Okay. You can see how easy it is to make these mistakes. Right there. So, with that said, I'm going to give you one, and I want you to do this one between now and Thursday and bring this in and turn this in on Thursday. So I'm going to just make one up here. Matter of fact, let me. Okay, and I'm just going to go 0, 0, 1, 1, 1, 1, 0, 0, 1, 0, 1, 1, 0, 1. Okay. There's the assignment right there. Right there. I'll let everyone write that down. Write this down because this is what you're going to be. Right there. Matter of fact, and you can also write this here as saying FABC equals 2, 3, 4, 5, 8, C, D, and F. Right there. In other words, this is the function right there. If any of those are high, any of those combinations, the output's going to be high. So that's another way that some people will write this. I just go through this table here, and every place there's a 1, I just put that there. So that's a shorthand way of writing it. Right there. Right there. Let's see. Oh, what have I got going here? Yep. There's a problem here. So that changes this here. This should be an A here. Right there. But when I started erasing the zeros and ones, I erased one too many lines I forgot to put back in. That's what I get for taking Benadryl. Sleep with a plugged sinus as I wake up the next morning, kind of foggy. So, does everybody, go back and look at the previous example right there, because it's In other words, this is the example you want to look at right there on how I did that. Right there. And you just apply that there. I don't know if this is right or not. It looks like it's 1, 2, 3, 4, 5, 8, A, C, D, F. Yeah, okay. Yeah, that's right. Any questions? That there? Okay, with that said, and I apologize for not feeling well today, but I definitely did not want to cancel today's class since we had not had a class for 2 weeks, right? That there. Just jump us right back into this right here, full speed up there. All right, before I abandon the ship here, let me go back to the book here a little bit here. Right here. And let's just kind of go through. All right, this is chapter 4, and if you look at this chapter right here, right there, you'll see that the first thing is we talked about the sum of products form. I've discussed that multiple times, right? Up there. So I skipped simplifying logic circuits using Boolean algebra right there. You know, I could spend probably 2-3 hours on just that subject right there. I chose not to simply because we don't do it this way, by hand. That's there. But again, it's covered there. I'm not going to hold you responsible for that section right there. So then we jump right into this designing combinational logics. I'm not going to get into that right now. So we jump right into the Karnoff math right there. So as you look at this book right here, you want to jump here, and this is the table where I got this material from right here. And you'll see that he goes through and explains this in a little bit more detail. He starts with a two variable map, a 3 variable map, and a 4 variable map. I only did the 3 and the 4 right there. And then he goes through here, and I suggest that you read this because I went through it relatively quickly. That's why I'm kind of going through here. He explains each group of 2 here. Why we do this group of 2 right here. There's a group of 2. Here's a group of 2. Group of 2. Here's a group of 2 across here. So these are 2 pairs. They're looping groups of 4, quads. He shows all the various combinations of groups of 4 right there. So these are a group of 8. Again, he shows all the various groups of 8 you can come up with right there. And then he goes through these examples right there. So again, a lot of I don't know about your other instructors, but I really, I put this book up there for a reason. That there is because he explains things like in more detail than I have time to do during the lecture right there. So as you go through and solve that problem, there are several more examples in this book here that he shows right there. Right there. So, and then we'll finish, once we finish that, we'll move on to the next subject right there. So, okay, with that said, let me stop my recording here. Up there.